Welcome. In this session on natural deduction, we'll explore what it means for a model to satisfy a formula. Before we do this, we need to understand one technical matter. Let's recall from predicate logic that sometimes we have a formula, and what we want to do is we want to substitute a term in place of a variable. And the way that we wrote that was we substitute a term for a variable. This was a syntactic statement. That is, we would go into the syntax, and then for every occurrence of x, we would replace it with the term t. And t was usually some other variable. When we're in a metalogic, we need to do something similar. And the way we'll do it is we'll refer to it by means of a lookup table. So when we're in our metalogic, we're given a set of function symbols and a set of predicate symbols. We then have a model. In addition to the model, we may need an environment, and this would be a set var of variable symbols and a map that takes each entry of the variables and maps it to a concrete element that is an object in the universe of discourse. To handle this kind of thing in semantics, so again we're in our metalogic, what we'll do is we'll refer to it as a lookup. And what we'll do is we'll say in our semantics, in our metalogic, what we'll do is we'll take the symbol x and we will concretely map that to an element a. And here it's possible that x is a free variable, or x might be bound within a quantifier, and it won't matter. Every time we see an x, we'll replace it with a concrete element of a. So this requires two things. One is, typically in this use, x is not in the set var, and the other is that a must be in the universe of discourse. This is a minor technical matter that we'll only use occasionally in these sessions. Now, let's consider when a model satisfies a formula. What we have to do is we'll have to be given, so this is within our metalogic, we're given a set of function symbols and a set of predicate symbols. And we have a proposed model, M, that may or may not include a set of variables if there are free variables in the formula, and it will include a lookup table. And we may have to employ this technical method for some variables. What we'll say is we will say that M satisfies phi, and we will say that this happens is we have a number of cases. So if phi is a predicate, and a predicate has at least one term, and it may have up to n terms for an n-ary predicate, then we substitute each, let's say the ith term, to find an object in the universe of discourse. So what we do is these terms may be functions, and we may have to evaluate a number of functions, and eventually what we do is we arrive at an object that's in our universe of discourse, and we then say that the model, and we write this as satisfies, using the lookup table, this predicate. And now what we have concrete objects, and I'll write them as A1 and so on to AN, and we'll say is defined as the predicate with these objects evaluates to T. That is the first that we'll do. The next we have to consider is, we can perhaps do it under here. We can say if the formula is for all x and then some other formula psi, then we will say that M satisfies, and now what we'll do is we'll use this technical method and we'll say, let's take this variable x, whatever it is, and let's map x to some A in the set, and say that for C holds for every A that is in the universe of discourse. And you can think of this, if the universe of discourse is a finite set, then you can imagine that what you're doing is a process of exhaustive search. That is, you would set A to be the first entry. You would map X to that first entry and evaluate this. Then you would take the second entry and so on. When the universe of discourse is an infinite set, you would have to do some different reasoning, and that different reasoning will determine whether or not you have shown that the model holds. Now, if the formula is there exists X of some formula, then we'll say that the model satisfies using a lookup of X mapped to A of C holds, and we can say for any A that is in the universe of discourse. And so what we'll say is that the model satisfies the formula there exists X psi, provided that you can find one object, and if you map X to that object, then this formula holds. And that is approximately what we mean. Sorry, that's not for any, that's for some. That is, we're saying as long as you can do it once. We then have, so this handles the predicate, this handles universal quantification, this handles existential quantification, and then we have the logical operators. And we can now enumerate those this way. If the formula is the negation of psi, then the model, then it's false that the model, using our general lookup table, because now we don't have any particular variable that we're going to insert it, if it's false, that the model holds for that. If the formula is a disjunction, so suppose it's psi1 disjoined with psi2, then this M satisfies this disjunction if the model using the lookup table satisfies psi1, or the model, using the lookup table, satisfies C2. Conjunction can be handled similarly. Is if the formula is a conjunction of C1 and C2, then we require that the model satisfies the left conjunct, and we require that the model satisfies the right conjunct. And the final one is material implication. And material implication is if our formula is the antecedent, material implies the consequent, then we will require that the model satisfying the antecedent logically implies that the model satisfies the consequent. These rules are approximately a way within predicate logic of handling all of the semantics that we had for propositional logic. The difference is that in propositional logic, this model was a row of a truth table, and now this model in predicate logic is more complicated. That is, it requires a universe of discourse, and it requires that we specify each function within the model, and that we specify each predicate within the model. And we'll specify each predicate by extensionally, which means by means of a not necessarily strict subset of the universe of discourse. And we've written this in a hierarchical manner, and you can imagine that what we could do is we could reverse this process in a parse tree, and we could begin at the leaves of the parse tree and then establish this satisfaction relation. So with this tells us if a model satisfies a formula. In subsequent sessions, we'll explore two related concepts. One is there any model that satisfies a formula, and do all models satisfy a formula?